So good morning, everyone. Good morning, dignitaries, and also the participants who had come for this conference today. And also a very good evening to those who are calling in from Taiwan. Hope I'm audible. Yeah, yeah. Thank you. So today I would like to cover, after the excellent presentation from Dr. Rajamanikam, I'd like to cover a little bit about the ecosystem of semiconductor and also EV, and also what Applied Materials is doing about enabling the India semiconductor mission. And as I was introduced, I am Sareen from the Office of CTO of Applied Materials. And some of you might already know about Applied Materials, and for those who are new, the Applied Materials is one of the oldest companies, semiconductor wafer fab equipment companies. And it was founded as a startup in Mountain View in 1967, around the time Intel started in California. And we are the world's #1 semiconductor and display equipment company. Our revenue last year was about $25 billion, and we spend about $2.5 billion in R&D every year. It's close to 20% of our revenue, about 10% of our revenue last year. And that's roughly about 20,000 crores or even more, and that's only on materials engineering. So what we do is materials engineering at the nano manufacturing level. The company has roughly about 15,000 patents actively maintained, and also we have about 30,000 employees in 19 countries. And one of the major centers is India. In India alone, we have close to 7,000 employees. And what we do is we provide equipment and technology for the semiconductor and display manufacturing industries, and we have been doing that for the last 55 years. And over the last 55 years, we are also one of the 3 companies to still remain in the NASDAQ 100. As a MNC company, we are one of the very few companies, only the 3 companies that is remaining still for the last 50 years continuously in NASDAQ. And in this picture, you can see some of our semiconductor equipment and also display equipment. So on the right-hand side, what you see is our typical semiconductor equipment. In the industry, the equipment is called tools, the semiconductor tools. And the display equipment is a very, very large equipment where all your displays come from, be it television displays, laptops, cell phones, mobiles, tablets, and everything. So over the last 55 years, practically every semiconductor chip that has been ever made on every advanced displays, if you have ever owned a smartphone, the latest smartphones, all the displays, it had come through an Applied Materials equipment. So wherever you buy from, it's LG, Samsung, Sony, most of the companies. So our customers are those big companies which makes those displays and semiconductor chips. And in India, our headquarters is located in Bangalore. We have over 6,000 employees, and what we do is we do complete engineering for the whole company, and also we also have a process and R&D team inside IIT Bombay. And recently, we have completed on April 20 years of our existence in India, and we are also working out of additional locations in India where we'll be building our own R&D facilities in India. And these are our other locations in India. So we are located in Chennai, which is in Ascendas, and we have about a software team of about 350 people. We have an R&D facility, as I said, inside IIT Bombay, and we are located inside IIT Bombay for more than 15 years. And of course, we also acquired a company in Coimbatore, or Tango Systems, about a few years back. And in Delhi, we have an office looking at government affairs and sales. And what we have done in India so far, it has been well known in the industry for some time, at least the semiconductor industry. So we created the nano manufacturing user facility inside IIT Bombay. We donated about the semiconductor equipment, the actual equipment used in the industry, to IIT Bombay back in 2006. And that was used by more than hundreds of universities and national labs and research groups in India. So in 2012, IIT Bombay and Applied Materials was awarded the creator of semiconductor R&D ecosystem in India. That was 10 years ago. And over the years, it has grown up tremendously, and now we have more collaborations and a lot of patents generated in IIT Bombay. And Applied Ventures, one of the venture arm of CTO Group, was also one of the funding agency of TESOL, and which is acquired by Hero Electronics later. And additionally, in addition to that, in the EV sector, in 2014 to 18, we did the largest solid-state battery research program in the world. And this was funded by the Government of India, Department of Heavy Industries, and multiple institutions collaborated with us, including SECRI from Karaikudi, SECRI Chennai, Pondicherry University, and then Delhi University, and so on. And there was an advanced battery manufacturing laboratory which was set up in Pondicherry. And currently we also have the professor who's is now part of QuantumScape, consulting with QuantumScape in California. And in addition to that, we also acquired a couple of companies from Tamil Nadu. One was Tango Systems, as I said, in Coimbatore. It's basically a Santa Clara based company, but based out of Coimbatore, and which was part of now an applied materials company, and also a DFM Sim. So DFM Sim is a simulations company for the semiconductor space, which was located 100 meters from here, from Vadabalani, which is also now part of applied materials. So we acquired these companies quite some time back. And since 2002, Applied is present in India, and we have been doing several semiconductor R&D programs with leading institutions, both national labs and academic institutions. We have collaboration program with IIT Madras on artificial intelligence, IIT Bombay, many departments, several, and also Indian Institute of Science. And we are also helping actively with state governments and central governments for quite 2 decades on creating policies for solar, batteries, and semiconductor. And a quick note about the semiconductor ecosystem. Of course, it was well covered by Dr. Rajamanikam, so I would just add a few things to it. So the bottom of the pyramid, what you see is a chip IP cores. So you know the companies, the famous companies that forms the semiconductor ecosystem. It forms the IP core owners, and then the EDA companies, the electronic design companies, and then the materials and subsystems. So all these companies in the complete pyramid is required for, and also even more than this pyramid is required for the totally to be enabled to form a complete semiconductor ecosystem. And as you've seen from various countries where semiconductor ecosystem is fully developed for the last 30 to 40 years, most countries don't have the complete ecosystem. For example, if you take it Taiwan or Korea, we have the largest chip, fabs there with Samsung and TSMC. They have the foundries. So on top of on the top of the pyramid, you have the foundries, TSMC, Samsung, global foundries, and so on. But then the equipment manufacturing comes from other countries, right? So one cannot have the complete ecosystem. So one country can have only what is needed and possible to, or also what IPs, core IPs and innovation that the industry can have. But then one of the key requirement for this is the materials. The third row of the pyramid, you can see the materials and subsystems. And then comes the wafer fab equipment. The wafer fab equipment are the key equipment that actually manufactures the chips. So if you take a fab, these are the companies here, the ASML, Lam, and Applied Materials is a wafer fab equipment company for semiconductor ecosystem. So we provide the equipment. And these go to either fabless chip companies and IDMs. So like for example, Intel, Samsung, these are all IDMs. So they make their own chips, and then which are used to given to companies. And then the whole ecosystem, you can see how it plays out. So companies like Google, Apple, they buy these semiconductors and then give it to assembly companies, and then these are manufactured as end products. And today you find semiconductors everywhere, right? So practically not just in cell phones and laptops, it is used in pretty much all components. And this is the overall semiconductor ecosystem where we are today. So today, if you see on the slide on the right hand side, in the market you go to buy a smartphone, you can find 3 nanometer and 5 nanometer products in the market. So practically there are only 2 companies who have the capability to manufacture those nodes. This is an old presentation from 2020. So practically not today you have 5 nanometers in the market. But then for most applications, you don't need such highly technically advanced nodes. You can even go with 65 nanometer nodes or even higher. So there are several companies which were in the past or even today, which makes that higher nodes, especially when it comes to power electronics and so on. So, and then when you look at the ecosystem on the left, the ecosystem always starts with the basic material, silicon. So you need to make silicon wafers, even whether it be solar cells, we need to have the basic silicon wafer, or maybe silicon carbide wafer, or gallium nitride, gallium arsenide wafers for compound semiconductors. And then you need different manufacturing process steps that goes through, from wafering, polishing, and then it goes to a fab. In a fab, it is, again, there are thousands of processes and inspection. That's where the wafer fab equipment tool comes in. And the industry, typically the silicon wafer comes in and becomes a chip after 3 months. So it takes a 3-month long period. It goes into hundreds of tools and inspected at every wafer. Every chip is inspected so that there are no defects. And then there's a yield criteria where it is all the defect products were taken out. And then finally, then it is packaged. And then it is packaged as a chip. And then again, it is packaged as a say chiplets or boards or SoCs by say OSAT companies or by even IDMs, and then given as end products. So that's a typical cycle of a semiconductor ecosystem. And where we are today, so if you look at the last, say, 30 to 40 years, on the x-axis you see the year, and on the semiconductor industry revenues. So initially it was all by the mainframes, so the IBM mainframes in the 80s and probably in the 90s. And then we have the era of mobility basically meaning your cell phones. So that was driving the market, the semiconductor industry. And today it is the AI. Because if you see the chips of today, it's no longer just say graphics or memory and processor cores. It's also neural engines, advanced AI engines that are being designed and also put inside the semiconductor chip. And we expect for the next 10 years, to 2030, that will be the biggest driver, and also the major revenue will come from IoT and AI, because almost edge computing, so every equipment will be talking to equipments, and there will be 5G and 6G, and there will be a lot of data that will be generated, and there's a lot of semiconductors required at every level. So that will be the biggest driver, and that will also be the biggest driving force for the semiconductor industry. And if you also observe how much silicon content is growing between the last 5 years, say 7 years, 15 to 20, in the 2015, about $100 worth of semiconductor was in high-end smartphone. Today we have about $170 worth of semiconductors. Semiconductors, we mean are not just the chip and memory, it's also the sensors. There are various MEMS sensors, microphones, even the microphone is made out of silicon now. The gyroscopes, accelerometers, all those are made out of silicon. Right? In 2025, we expect it to be about $275 of silicon content in a high-end smartphone. Similarly, automotive industry. So the global average is about $310, and it will expected to be about double by another 5 years. In spite of the shortage, we'll also look into it when you go to the EV ecosystem. And the biggest driver is again data centers. The data centers have CPU and accelerators, so that's about $5,600 worth of silicon content is expected to be there by 2025. And of course, smart homes, there is always a big driver, but it's a new area entirely. And what Applied Materials is doing, so we have something called PPACT. So this is power, process, area, cost, and time to market. So what we are working on right now is new structures. So basically gate-all-around transistors. So earlier we used to have FinFET, 3D FinFETs, and now we are looking at gate-all-around, and also 3D NAND and 3D RAMs. So which is again going at even increasing the multiple layers than what is already present in the market. We are looking at new materials at the gate, at the contact, at interconnect, and new ways to shrink. So EUV is a big driver. So EUV is finally now well established in the industry. So extreme UV for lithography, and materials enabled patterning. So at extreme UV, you have very limited number of photons. So again, how much you can do is also extremely limited. So the materials becomes very, very critical in how we select those materials and also process them. And one of our biggest thrust areas now is advanced packaging. So advanced packaging, primarily because, of course, there are a lot of slides in Dr. Rajamanikam's slide, which covered very nicely about advanced packaging. We no longer have chips, so we have chiplets, right? And it's no longer wafers of 200, 300 meter diameter. So now it all comes in panels, so 600 by 600 meter panels. So you have different kinds of equipments, different kinds of processors. It's no longer a single chip. So memories, chips, multiple chips are joined together to form one chip. The classic example being the Apple Silicon M1 chip, or even the GPU cores by NVIDIA. These are all advanced chiplets, and more chiplets are integrating even RF and modems and even HBM memories. So there's a lot of thrust on advanced packaging. So we will also see some of the equipment that we are doing being set up and from our portfolio for advanced packaging. And the advanced packaging is gaining overall momentum. So for example, we expect that to be about 48 billion out of the 90 billion market in 2025. And the conventional packaging with so wire bonding and all as a growth rate is much smaller. So basically the CAGR is less than 3% for known packaging. So we expect that to be much higher, and this is from last year it was more than 50% year-over-year growth. And Applied's position is we are number one in bond pad, bump, and TSV. That's through silicon via. And we have a full flow fab with a broad product portfolio. We have a most advanced packaging lab in Singapore. I will also show some pictures on that. So what we do is we want to bring down the resistance, bring down the power, bring down the area, and increase performance. That is our main goal in advanced packaging. And if you look at the chip design overall, from the Moore's law and the ITRS maps and the olden days, the PC era, the wire bonding was very popular. And flip chip was more popular for the mobility, for the cell phones. And today we call it, for the AI, we call it heterogeneous integration. So basically what it means is you have multiple chips being integrated together, and the traditional Moore's law scaling has its own limit, but of course people talk about more than Moore and Dennard scaling. There are various ways it will continue to improve, and the number of cores have been increasing tremendously over the years. And here is an example of heterogeneous integration. So you can see this all forms a single chip. So you have an image sensor, an RF, a GPU, CPU, memory, and all these need to be packaged. So this is something that what we call advanced packaging. And for this, you need very extremely specific kind of equipment. And these enables integration of logic, memory, even sensors and powers into a single chiplet. Right? So for example, you can also put in SRAM and logic, or HBM, GPU and logic. So you can, on the picture on the right hand side, you can see advanced substrates. So Dr. Rajamani also talked about substrates. So advanced substrates are needed, especially from the material side. There will be material suppliers who will be supplying advanced substrates. And these are still at a higher micron. It's not necessarily nanometers. And what we have from the portfolio product point of view is we have different kinds of equipment. These are like CVD, etch, Endura is a PVD equipment, and also inspection equipment. This can be used to do different processes, manufacturing, basically thin film processes, thin film material deposition, thin film removal, and for example, say barrier seed deposition or copper pad fill, and also planarization. Reflection is a CMP tool. So there are different kinds of processes that are available. These are traditional equipment, again specifically fine-tuned to the latest advanced packaging portfolio. And we also have hybrid bonding for both wafer to wafer and also die to wafer, and also special laser annealing process for the packaging industry. And one of the additional tools that we have is also much larger than the traditional silicon wafer. On the left hand side, you can see that a 300 millimeter wafer. That's the size of the 300 millimeter wafer with the chips. But then on the advanced packaging side, industry is now moving towards panel, which is rectangular panels, which is 600 by 600 or 610 by 475. So Europe is also working on different sizes, but then 600 by 600 is pretty much the norm now. And you can do multiple chiplets in a single substrate. And package areas can be really large, about 10,000 millimeter square. And because round wafers have poor efficiency, so this is one of the most common things that are going to happen, and it's already happening. And this is one of the tools that we have. So applied Topaz PVD system. This can take substrates by 600 by 600. And there are several equipment that have been in the industry using this for in the last 5 years. And in addition to that, Applied also has a global infrastructure, and we are probably the only company in the world to have our own fab. So where we test out all our equipment and processes. It's a Mayron Technology Center located in Santa Clara. It has a class 1 clean room with 120 equipment and 300 millimeter wafer fab equipment for the industry. So every tool that we make, you can make a complete chip out of it inside our own headquarters. And we also have a APDC, which is in Singapore, which is exclusively for advanced packaging, which is again, we have 11 applied platforms, about 40 equipment, and we have about a 17,000 square feet clean room, and we will be adding 24 new tools this year for wafer level packaging, mainly to look at copper pillar, bumps, fan out, and also TSVs. And the primary focus of this fab is to, this lab is to do advanced packaging with UBM, PVD, ECD, PR strips, and also defect reviews. And so primarily we do this to win the global competition, to win the IoT inflection that is happening. So worldwide, if you see the new multi-billion unit markets, so basically your wearable technology, smart homes. Am I running out of time? Okay. So healthcare, smart auto, and so on. And all these are enabled by semi-innovations on PPAC. So I'll quickly also cover about EV, so in the next maybe 2 more minutes. Yeah. And if you look at ICAPS, applied as a special group, we need to look at IoT, auto, power, sensors, and also communications for the future, the 5G and 6G technologies, and also photonic devices. And there is also a huge requirement coming from the auto industry, be it be radars, LiDARs, or also RF technologies and power, extending power technologies. So if you look at the transition to EV, the semiconductor content is, we expect it to increase by 4 times, up to close to $2,000 in the next years, mainly power devices, sensors, microcontrollers, and also others. So between traditional EV and also ADAS. And here is some comparison on silicon carbide with silicon. So if you look at silicon, it's about, wafer cost is about $30, and silicon carbide is $800 a wafer. And what it can do is breakdown voltage is 10 times. It can also be higher, especially required with respect to lithium safety. For example, most of the European manufacturers, they are moving to 800 volt systems for their vehicle. So pretty much 400 volt was a norm, and where you need high power electronics, which can be enabled only by silicon carbide. And these are some other companies who are already doing 800 volt systems. And I also have some slides on the battery, lithium battery ecosystem. So typically the batteries that are used are lithium batteries. The primary EV ecosystem, they talk about batteries because that is the core of the EV industry. Of course, the ecosystem also has motors and drives and converters and so on. So traditional lithium ion LFP batteries or NMC batteries that are available in the Indian market, it's typically the battery capacity is defined by watt-hour by kg, the gravimetric density. It's about 75 to 150 watt-hour per kg. That's the battery that you have on market as assembled battery or at a cell level. But the industry needs much higher capacity because you want good higher capacity for longer mileage and also fast charging capability. On the right hand side, you see the battery European Union 2030 map, and also what USA and Japan and China is doing. And currently you have on market 200 watt-hour per kg. But then there is also additional requirement from the ex-VTOL industry. Basically, electric vehicles is not just limited to 2-wheelers, 3-wheelers, and cars, and also for electric vehicles, helicopters, and electric personal mobility airframe vehicles. So these require even higher capacity. There are currently a couple of companies manufacturing batteries for them. So one is an applied materials company called Zen Labs, and also Amprius. There is another company which is making up to 800 watt-hour per kg. And due to deep discharge requirement, you need really high capacity energy devices. And in applied materials, what we are doing is to put lithium metal batteries. There's also solid state batteries and also pre-lithiation. So we can increase to up to 450 watt-hour per kg and up to 1200 watt-hour per liter. So these are some things, the equipment that we already have for this, and we are working with various companies on this, and this would be coming sometime in the future, about 5 years' time. But currently the industry is looking at traditional known ecosystems. So I give an example of ecosystem from Europe. On the left-hand side, you see the battery manufacturing plants currently being established in Europe, primarily looking at LFP and CA and other battery systems, and also the materials ecosystem. So primarily lithium hydroxide or active materials, the carbon, and also the battery grade copper and so on. So this is typically an ecosystem in Europe currently, and the battery ecosystem in India requires if not similar initiative to be competitive. And if you look at automotive industry, the automotive industry is also moving towards new technologies, the connectivity, electrification, ADAS, and also sharing. That has become common. So most companies talk about CASE, and as you see, you require 48 volt to 12 volt DC-DC converters, and also several silicon carbide electronics that would be required for future automotive companies. Yeah. So I would stop here, and thank you. If you have any questions.
If you have any questions, yeah, please feel free.
So I am Ashok from TISC, sir. In Tamil Nadu, especially for the battery assembled units are coming up. As you said, so lithium ion and lithium ion phosphate battery cell manufacturing units are coming up. what is the scope and how the MSMEs will be benefited out of this?
So I think currently there are battery assembly companies are coming up. Yes, you are right. But then they import the cells from other countries. So I think the cell manufacturing ecosystem has to start with the battery grade materials. But also right now for battery assembly, the battery assembly industries would have to work with their customers, who would be the automotive industries, and define what kind of battery packs they would need. And battery packs is for two-wheelers could be straight away parallel series connection with air cooling, with not much the battery management system. But then battery for packs for automotive industries are even highly advanced. They need to have specific cooling and also specific chemistries and throughput and much more stringent requirements if they are exporting the vehicle and so on. And also safety is a very, very important aspect. So I think that the MSMEs need to work with their end customers on that.
Thank you. If there are more questions, during lunchtime we can have an interaction. Sorry, we're running out of time. We just want to give mementos to the two speakers. Thank you to the speakers. Shiva. We'll start the next session. Electronics assembly and raw materials required for electric vehicles. There will be three speakers. The first speaker will be Dr. Ravi Bhatkal, Managing Director, India, McDermott Alpha Electronic Solutions. Of course, he doesn't require an introduction in Chennai, but I'll just cover a very brief introduction. He serves as the Managing Director, India, for McDermott Alpha Electronic Solutions, which includes the Alpha Assembly Solutions and McDermott Enthon businesses. Prior to this role, he served as Vice President Energy Technologies at Alpha Assembly Solutions, where he built and scaled a new global business in the alternative energy and energy efficiency value chains. Previously, Ravi served as the VP and General Manager of the Global Engineering Product Businesses at Alpha and led global strategic OEM marketing, strategic planning, and the corporate new business development initiatives at Cookson Performance Materials. So may I invite Ravi for this?
Can you hear me now? Yeah. So thank you to ELCINA for inviting me to speak today. And I thought I was asked to speak on electric vehicle and semiconductor ecosystem in India, and I thought I'd just focus in on power electronics because I think it's a really, really important area. I won't talk about batteries and other things that also fit into the electric vehicle infrastructure. So just a quick introduction regarding our parent company, Element Solutions. We're about a $2.5 billion advanced materials and specialty chemicals company headquartered in the US. We are a public company. We have operations in 50 countries, including India, and two major sectors. Electronics is the larger of the two, and then we have industrial and specialty, including coatings, graphics, and offshore oil. In electronics, we span essentially the entire chain from back end of line semiconductor to finished system. So every layer of the electronics industry is a customer of ours on a global basis, starting from device design on to device, original equipment manufacturing. These are just allocations globally. I won't get into it. We're in all major regions globally. In India, we've been here for 91 years. It was founded in 1931 in Calcutta, and then we moved to Chennai about 50 years ago. We've been headquartered in Chennai since. We have our global R&D center in Bangalore. We have manufacturing also in Bangalore and Pune, and then we have a technical test center in Manesar and Gurgaon. This is just a graphic of all the different technology solutions material solutions that we provide, from semiconductor all the way down to finished products. So this will be available, so you can review it then. But we started the Damascene copper technology way back in the mid 90s, and it's evolved from there at the semiconductor level. We are into redistribution layers and copper pillar bumping and all the other areas in the semiconductor space. And lately, we've been focused quite heavily in the power electronics sector, which I'll talk about in a second. So, why is power electronics really becoming important? So, this is just a graphic that I came up with about 12, 13 years ago, looking at the entire ecosystem that we're a part of. And we meaning I'm talking about electronics industry as a whole. What I started noticing was that the energy flows and information flows were intertwined and began to be intertwined very early on, about maybe 15 years ago. And how energy is generated, transmitted, distributed, and consumed became really, really important. With climate change driving, becoming more important, it's driving the need to go renewable, distributed, and that drives electrification. Electrification drives power electronics. So, as electrification is growing, the conversion of energy from one form to another requires power electronics, and that's the critical piece. So this is a very core technology space that is emerging and growing substantially, and which India really needs to be a part of. So just a quick note about EV powertrains. You can think about it as three core areas. You've got the battery system, which provides the storage of the energy and then provides the energy through the power electronics to the electric motors. And power electronics consists of the inverter, converter, then you've got all the interconnect materials, including lead frames, bus bars, heat sinks, etc. And then the control electronics. The battery system itself is made of the battery cells, the packages, and the entire system, including control, battery management system, control electronics, and junction box. And then the electric motor is another critical piece of the EV puzzle there. So what is power electronics? Power electronics is nothing but the application of solid state electronics for efficient and reliable conversion of power from one form to another. So you can take a battery which generates DC power, take it through an inverter, which is a power electronics system, and convert it into AC power that gets fed to the motor. And then you've got AC being converted to DC to charge the batteries. You'll see 4 boxes there at the bottom. There are 3 core technologies that exist right now for at the semiconductor level for power electronics. It's silicon, which is what started it, and then silicon carbide and gallium nitride, which are each used for their own in their own areas of importance. And the devices are IGBTs, diodes, MOSFETs, thyristors, etc. The second and third box is really how do you improve and increase the efficiency of the device through thermal management, and then making sure that these devices are reliable through a wide variety of tests and protocols. And the last box is the different forms of converters that exist in the field. The segments of application are very broad, and I'm sort of giving an overview here. I'm sure a lot of people here know about these areas, but consumer, which is typically lower voltage, lower power applications, use discrete packages. Automotive applications, depending on whether it's low, medium, or high power, use discrete mini modules or modules. And then industrial, which are very high power, high voltage applications, end up using a combination of discrete modules and products like thyristors or press packs. the point I'm trying to make is that this is a core technology, no matter what application you're considering that is involved in electrification. It is very, very core, because power conversion is fundamental to using the correct form of electric power. How big is this space? YOL actually has done a great job in the space and in developing some really good information. You'll see that the market overall is about 2x of what that says in the band that says power inverters. So you're basically looking at roughly $140, $150 billion market globally at the systems level. And as you go down from systems at 140 to 150 billion, inverters are about 70 billion, semiconductor packages and modules are about $20 billion, and then wafers at the wafer level, whether it be silicon carbide or gallium nitride, you're looking at a $1.5 to $2 billion market. So it is very substantial, and if you apply a simple ratio, which is that today India is probably 5% of global electronics manufacturing, a fair rough estimate. You apply that 5% number here, you are still looking at a very substantial market size, $7.5 billion at a minimum for power electronics if it is located here. And today it is just a wide open space in India at the moment. So just an example of where these packages and modules would be used in a hybrid or an electric vehicle. You'll basically have power modules for the main inverter, and then the onboard charger and DC-DC converter will end up using packages. Just examples of where the different devices are used. If you look at the main traction inverter for a high power vehicle, you'll end up seeing silicon carbide being used, silicon carbide MOSFETs in particular, and silicon IGBTs, and onboard chargers may use silicon carbide IGBTs, and so on. So you can actually map the usage of different devices here in the vehicle. So I was asked to talk about localization opportunities, right, and partnership opportunities with Taiwan and so on. Coming back to that same graphic of the ecosystem, the band on the right, the column on the right are the technologies that really need to be localized. And I talk about the technology space because it is fundamental to developing a full ecosystem on the ground here. And those major platforms are thermal, electrical, protective, energy conversion, and RF for power. I don't have time to go into the details, but anybody want to know more about this, we can talk offline. So how do you look at the ecosystem in order to localize? You basically split it. I know both Raja and Sarin talked about the how do you look at the ecosystem? It's fabrication, packaging, board assembly, final assemblies. Simple way of looking at it. There are 7 key elements, and there's an 8th one, which is people, but 7 physical inputs and enabling activities that are really important at each level. You've got, whether you take packaging or fabrication, for example, you're looking at materials, components, and equipment, the physical inputs, and then the enabling activities are design, modeling and simulation, manufacturing, and testing and reliability. If you really want to if we want to develop a robust ecosystem on the ground, then these need to be located here in terms of capabilities, in a more systematic way, not concentrated and isolated, but in a more systematic way throughout the system. So what is needed is fundamentally ecosystem building, which includes technology and manufacturing investments and incentives that is happening through the PLI schemes and spec schemes. That includes investments in design, modeling and simulation, manufacturing, testing and reliability. Design, India is very, very strong, as Raja mentioned. Modeling and simulation as well. I think the other two is where we now need to focus locally. And then, of course, you've got materials and chemicals which support the entire ecosystem that need to be localized. The third part rather, is what Sarin mentioned, where Applied has done a great job with IIT Bombay and other areas, other universities, is the industry, university, government partnerships, replication of the full value chain at university campus, so that it enables skills development, sustaining technology growth, and enabling the scaling of the industry going forward. Because if you don't have the right people, this industry will not scale. So it has to be thought of in that way, and we got to take the steps to establish these ecosystems in place. Getting to the nuts and bolts of the actual technologies, there's clearly opportunities for silicon carbide and gallium nitride wafers and devices. I know of at least one PLI application that is for silicon carbide, and one university-based ecosystem that's coming up with gallium nitride, which is a real fab. And in addition, of course, there are companies and global companies that are locating here for materials and chemicals. We are here as well. And then I think testing and characterization we will need to work on going forward. The discrete packaging and power module design and manufacturing capability, that again, the design capability is here. We really need to develop both the industry packaging OSAT capability as well as university-based capability for packaging. And again, breaking that down, it's lead frames, interconnect materials, protection materials, that's molding and potting compounds, substrates, DBC, DPC, etc. And then testing and characterization, and then systems design and assembly for control electronics, module to heatsink, and cooling systems. This is just a quick graphic of what we do in this space. We have looked at it at a systems level all the way from power devices, semiconductor level, to the finished system on the power electronic side. The same on the battery side. We're not in the active battery space at the moment, but everything going in and out of the battery, including protection, and then the electric motor space. I'll just give you one quick example of sintered technology, sintering technology, which is applied to high power power conversion. We've implemented this technology globally now in major EV platforms. We are seeing about a 30x reliability improvement over soldering materials. It goes from maybe 12,000 to 350,000 plus power cycles. And more importantly, it enables high power operation, high temperature operation, which you need for silicon carbide. And it also decreases the size and enables a much smaller cooling system. The benefits are huge, because if you look at power density, you could get about 9x to 10x power density improvement with 6x peak performance improvement, while reducing the weight and the cost of the inverter in this case. So just some quick examples as to what certain technologies can do for the industry in a significant way. That this actually increases the range of the vehicle. So these are technologies that we can bring here, because we are capable of doing it. We have a very good infrastructure here, and we can bring these technologies here. And I think that, in my view, there's nothing to stop localization today of since we're talking about power electronics, nothing to stop us from doing this. I think it's just a matter of pulling the pieces together and making it happen in terms of investment in technology. Thank you.
Thanks a lot, Ravi. Before we go to the next speaker, one announcement. Once we finish this session, people are wanting to do the B2B with the Taiwanese companies can continue. Of course, most of you will go for lunch, but people who want to stay back, ELCINA people will help you with that. Thank you. I would like to invite Mr. Brian Tsai from Wali, Taiwan. Good afternoon, Mr. Tsai. Mr. Tsai is currently nominated as Executive Director of Merle, India. Mr. Brian's achievement includes generation of more than 20 million business in less than 7 months, expansion of dealer shops up to 300 numbers in less than 5 months. Mr. Brian is in charge of replacement market of Gujarat, Rajasthan, Maharashtra, Goa, MP, Assam and northeastern states. Mr. Tsai.
Yeah, am I audible?
Yes, please. We can hear you well.
Oh, okay, great. Yeah,
Go ahead.
thanks for the introduction.
Yeah.
Yeah, good afternoon again. For thanks for the introduction. I think first my gratitude toward the organizer, ELCINA and the Triple I to make today's event happen. And again, I'd like to welcome all the on-site participants there in Chennai and some online audience here from Taiwan as well. Thank you for joining today's event with us. My name is Brian. On behalf of Huali Industrial Corp, I'm very excited to talk to everyone here today. Before I start, I think perhaps I'll give a quick introduction about myself. I think earlier the speaker already mentioned some of my experience there. So I had a privilege to work and live in India back in the year of 2011. And over the years as a sales experience, I am very proud to service plenty of the local company and partners, including Lube Electronics, Honda Motorcycle India, or Wipro GE Healthcare. And I even had a chance to support plenty of the government organization like Bahara Electronics Bell, BARC, or the ISRO, to name a few. And I'm very happy to join Huali early this year because we had an exciting plan to service local industry, including the plastics industry, electronic manufacturing, and the EV ecosystem here. So I would also like to take this opportunity to say that currently we are looking for some strong local partners and experienced sales talents in different vertical market there. So please feel free to reach out, through my WhatsApp number here or email here right after this meeting. In my section here today, I will first, introduce about the company, who we are, and what product or service do we offer to the market. And then I'll give you a few examples about our current business in India, including how we service our local client like Dixon Technology or the Sabic India, and some of the Taiwanese company here who has the local operation there in India. And to conclude in the end, I actually have few suggestions, one simple suggestion only, and hopefully with that can help the buyers or suppliers from India or Taiwan to better work with each other. And my suggestion, I think I would like to echo to Dr. Ravi first. I think localization is very important indeed. So thanks to mention that already. Yeah. So Huali is a leading IC component and advanced material distributor for more than 5 decades. The company established itself back in 1968. We are also an equipment and solution provider for industry like PCB and plastic, electronic manufacturing, EV, new energy, and semiconductor. And because of the strong demand after the pandemic, we are very proud to set a new revenue record of $2.5 billion last year. That's approximately 80,000 crore Indian rupees. And currently, we represent multiple brands and have a versatile portfolio to offer our customer the experience of one-stop shop. Headquartered here in Taiwan, we have a local operation and distribution network to cover all the major cities and countries across APAC or North American region. And this year, this is what really excited me about, is that we had a plan to add 3 new offices, including from north to south, Delhi, Bangalore, and Chennai, to service our local client, and together with some of the local partners, of course. So leading by the strong demand for 5G, AI, high-performance computing, and EV from the market, we continue to grow with our customer by supporting them all kind of product from high performance plastic to high resolution dry film that use in IC substrate or some other advanced material components here. And the strong partnership with the customer and the long-term relationship with OEM is also another reason that despite of the impact of the pandemic, our revenue continued to grow. And with a very good performance the first quarter this year, and our expansion plan in India and other vertical market, we are aiming to achieve 2.8 billion or even higher this year. Our technical partner, including company, for example, like AGC Group from Japan, we supply their product like flowing film, flowing solvent, and resin to Semicom, OSA company of PCB manufacturer here. And you can see the JSR Corporation in the middle. I think one of the speakers also mentioned about the product UV. So their product UV specialized photoresist. Currently, there are only 3 companies in the world have the capability to manufacture it. And as the exclusive and authorized distributor here in Taiwan, we help our customer to supply to TSMC, the world's largest semiconductor foundry. And on the right-hand side here, we also help Asahi Kasei and their product dry receipts to capture more than 80% of the IC substrate manufactured here in Taiwan for the last 20 years. So I won't be able to mention all the brands and the product here, but just give a quick example. For example, the LCP from Curare and the silicon carbide bare die from Rome. So our advantage is quite obvious because we have so many reliable partners that has been working with us for decades. And our customer can easily source all of the product they want from a single supplier. Again, here's the list of our portfolio here. I just categorize them under 3 major sectors here. For example, the engineering plastic, we provide product like PPS, LCP, PET, PPT. And in optical electronics, we are capable to supply more than 90% of the material in the LCD or ADTV, from the IC component level to module or even the packaging material. And in semiconductor industry, we are mainly service our foundry and also client with the raw material or the process required chemicals. And as another value of Huali here, because of our wide distribution network, we also sell their product. For example, here we also sold the wafer or die to some other client. Again, here this block diagram showcase what we offer in the component level, from the silicon carbide SPD MOSFET to photocoupler to microcontroller unit, and other like resistor, inductor. And of course, we can modularize those components into a solution to offer to our client. So now you have some idea what we are offer by now. I thought maybe I can show you who is our customer there in India as well. So I'm very proud to say for the last 3 years, Huali's revenue in India has grown 2 times bigger, and right now it's close to 20 million by last year. And not only we are servicing clients, local clients like Dixon Technology or the other home appliance brand like Oneida and Havells, we also extend our support to many of the existing customers from Taiwan to their local operation in India. For example, the Foxconn and its group company Every Technology, they have some PCB production line currently using some equipment supplied by Huali. So the first case I want to mention here is how we support Dixon Technology or Oneida and Havells. We all know because the pandemic, the demand for the home entertainment system, especially television, has ever increasing since the year of 2020. And Huali here, we had a long history supporting the display manufacturing history. Not only we provide from the IC component to plastic raw material to the manufacturer, we sometimes also help our customer using our worldwide network and logistics service to promote their product. So in this case, actually, Dixon Technology and Oneida, they want to level up their manufacturing capability. So they are not satisfied with only the end assembling. They also want to complete the SMT themselves. So in the beginning, we help to provide ready-made TV mainboards to them, but gradually we scale up their manufacturing capability. So now they only need to source the component from us. So this kind of upgrade process has actually tightened up the relationship And Huali here, we are very proud to be a silent supporter behind, this Make in India policy of the government Modi G, of course. Again, this is a example what kind of plastic can be used in the display PD manufacturing and is supplied by us. A similar example here for smartphone. One more case I'd like to mention here is that, when Sabic India, they had this requirement for the protective film made by Torre used in between the PC optical sheet to protect the damage during the transportation. So one of their, I think, critical to quality point is that supply needs to be very stable. And Huali here, because we have long-time partner with both the original supplier Torre and end user Sabic, so we had a perfect sales record to convince Sabic that yes, we can, I think, extend our supply to India as well, not only just here in Taiwan. So our good reputation and the trustworthy history with the both supplier and user makes us the number one choice here in this case. Here, this is also give you some idea. Currently, Huali, we provide a charging bio solution for 2-wheeler, 3-wheeler, 4-wheeler here. And like Dr. Ravi mentioned, we actually also focus on the power electronic here. So for example, you can see some silicon carbide or gallium nitride components that is also we are trying to offer to the EV ecosystem. And here is the example of what kind of plastic product can be used in the auto part. And of course, it's supplied by us. Okay, so this is to conclude. Actually, I have only one single suggestions, and to finding a synergy, I believe, is the key to build a partnership here. And of course, the localization is also one is very important here. So I believe communication, how can we communicate with each other fast and clear is the key. Especially the demand side there from India should be shared the detailed information, what is the current market status, what is the pain points, what type of solution should be introduced to the market. That should be clearly shared with your partner. And then the supply side here may be able to evaluate whether there's a true opportunity based on the commercial or technology intelligence share. So, and if you want to be cautious, of course, we can always sign the NDA to protect both parties. Deposit or penalty clause in our official agreement can always help to keep everyone play by the rules as well. So, but I believe the most important thing is still keep the communication clear and straightforward. So gradually the trust will be built and the business can be grow together. Yeah. So I think that's it. That's cover all my section here today. I want to thank everyone here for your attention again. And just like I mentioned again, if you have any business proposal requirement, or any question, I'll be very happy to answer them after the meeting. You can reach out by email or WhatsApp to me. And most importantly, I'm looking forward to meet everyone in India very soon. Thank you.
Thank you. Thank you very much, Mr. Tsai. It's quite amazing that you have such a wide range of products to offer to India, and personally you have a lot of experience dealing with India. It's very nice.
Thank you.
Thank you very much.
Yeah.
May I now introduce Mrs. Jim Chen, a Senior Sales Representative, Delta Electronics. Ms. Chen is currently working as India Senior Sales Representative for Delta, which was founded in 1971 and is a global provider of power and thermal management solutions. Its mission statement to provide innovative, clean and energy efficient solutions for a better tomorrow focuses on addressing key environmental issues such as global climate change. Ms. Chen has 9 years of working experience in PCB printed circuit board industry and 7 years experience in industry automation. Mr. Chen, please.
Hello, I'm Mr. Jim. Is it my voice audible?
Yes, please.
Okay. Thanks for everyone to join today's event. Today, I'm going to share the potential for the cooperation with the Indians companies and export markets. That is the topics I'm going to sharing during this period. So before that, I have some commercial time. Okay, so just have a very short introduction about the Delta Electronics. Our company founded in 1971. So we are the world leader in the switching power supplies and also the DC blastless fans. And our founder, Mr. Bruce Tang, actually is our chairman and also still working in the Delta Electronic right now. So our sales revenues for the worldwide in year 2021 is come to the 11.2 billion US dollar. The mainly contributions coming from the telecom power, industrial automations, and also some like the renewable energy, and also the EV charging infrastructure solutions. So this is the main business what we are continue to grow in this particular field. So the next I'm going to have the cover the today agenda. So I will have a short talk about the market overview about the India, the EV, and also the second one I will talk about the potential for the collaboration from the India India factory India I mean the supplier point of view, and also from the Taiwan supplier point of view. So this will be covered the three topics. One is about the mobility solution, charging infrastructure solution, and also the hardware and the software solutions. So in the conclusions, actually, I think if you look at the India, the location actually is the center of the planet. If you look at this, actually, India is not only for the domestic market, also can for the export market. This is the concept. I'm going to bring it out during today presentations. So let's move to the next slide. So first, let's look at the market overview. Okay, this is the electric market forecast in the year 2025. So if you look at this, this is the resource. This is a research report from the Frost and Sullivan. So they will have 3 million of the two-wheeler motorbike or the e-scooter to be happen or to be coming up in 2025. They will have a very huge demand, especially in the two-wheeler. And the second one, actually, if you look at this, e-auto will have 100 times grow from 5,000 to the 540K quantity in 2025. So that is a very big market, especially for those player or for those supplier who are going to enter the EV field. So this is the two growth engines which is to be forming up in India. So how to catch this opportunity? That is a very, very important for the Taiwan supplier and also from the India supplier, and how we can working together. That is also a very key message I'm going to deliver at the following slide. So moving to the next slide. Sorry, I'm okay. So moving to the next slide. Okay, what kind of the collaboration we can working together in order to enter the EV market? I'm going to bring you from the India point of view, and I'm going to bring you based on the Taiwan point of view. This is very important. When we cooperate together, this will be easy for both from the Taiwan supplier or from the India supplier to enter the EV market and shorten the learning time. So coming to this mobility solution corporations, first I will have some macro point of view to you to let you understand that where is the strong part where is the strong part from the India point of view. For example, from the clockwise, actually, as everyone know that actually India very strong in have a lot of experience in the electronics, and we also enter very early in the battery pack solution and technology. So for the EV control technology, that is also we enter very early. I mean, there are a lot of players starting to develop EV solutions, powertrains, and all these related technology been running for more than 10 years and even more than 15 years. So that is the strong points what I'm going to point it out from the Taiwan point of view. The last item actually is very important. Electronics component and semiconductor. I think today we talk a lot about the semiconductor electronics. This is a must. So that's why we have to pick it up. Which one is the strong part from the India? Which part is the strong part of the Taiwan? So if both parties we can sitting together to do the select, then we can working together. And from the Taiwan point of view, from the India point of view, we can shorten the learning curve in order to enter the EV field. So in order to give you more detail, I break it down. I think let's use an example to you to have a collaboration potential. So I'm using two-wheeler as an example because actually, if you look at the research report just now I'm showing, they have 100 times, 23 times of the growth of the two-wheeler in the Indian market. So I using different color to list out which part that is a strong part of Taiwan. From the left-hand side, so if you look at this, the DC-DC module, onboard battery charger, the motor drive, and also some of the infrastructure like a charging station, battery swapping station, and home charger. That is a lot of experience is being built out in the Taiwan. We have multiple player and also the OEM is been running more than 10 years in this EV field. And from the India, the supply chain, IC engine OEM machine maker, they are very strong in the know-how of the VCU module and also some display and reducer, especially in the mechanical part and also the traction motor. That is very important for the India player. If you are going to enter it, that is first you can easily to enter through this kind of the mechanical part, component part. I'm also put the battery in the middle. I think actually battery is the heart of the EV. So we have to having this as a very important technology either in the Taiwan or either in the India. So that's why both parties we can consider working together how to co-working for the battery portion. So in order to give you more idea, I summary one table. So this is based on the from the material point of view, from component point of view, from the system point of view, and also the system integration, development, and assembly. So I will going to use the two parts. One is the, if you look at this, so I'm using the blue color to point it out here. If you look at the blue color, so the blue color actually we from the Taiwan supply chain or Taiwan player, they're having a lot of experience, especially in the battery material, automobile electronic material. From this is from the material point of view. On the components, we have multiple player who are very strong in the drive, battery, DCC module, battery charger, and also the visual module. And for the mid-range, like power systems, battery exchange systems, battery management system, this is also have a lot of players in this field. So from the material to the component to the system integration development. So this is the from the Taiwan player is been running for the most of the Taiwan supplier having this experience. I'm using another one. If you look at this, there are some overlaps of the India player also. If you look at this DC-DC battery charger or the battery exchange system, battery management system, there is some overlap. So I'm using this slide to give you the summary. So if you look at this, there are multiple portion. Some of the player they can focus on the which is the strong part of the India. and some of the portion is strong part of the Taiwan. And some of the part, I put the multiple color here. From here, it will be easy for the two supplier or to the player who are from the India side or from the Taiwan side. Both of us can sitting together. I'm going to share here. And on the other hand, for that is for the powertrains and also some of related to the vehicle. But if you only have a vehicle, they are not enough. Infrastructure is also very important solutions in order to support your EV promotion to the Indian market. Without the infrastructure, the EV promotion is very difficult to let everyone accept it. So infrastructure is a necessary. So I'm going to here. I think we talk about the EV. I think we talk about the green energy. So from the green energy or from the energy generation, so this kind of concepts, actually it should be the whole ecosystems what I'm going to show here. So from the power generation to the charging infrastructure, to the battery swapping station, to the, let's say the mobile battery swapping station. This kind of concepts you have to consider as overall solutions. As you know that the power quality in India or the power shortage will be another factor will affect the EV promotion. So if you have this overview of the solution, it can help the user. They understand that if we have the total solution of this EV power charging solution or the infrastructure, this will be help the user to accept the EV. So this kind of concept is necessary to be bringing up, I think, during this event. I'm also using the same color. The blue color means there are multiple players from the Taiwan is already in this field. If you look at the orange color I'm pointing out here, there are also multiple players of the India is already entered this field. So we can base on this to think about how both parties to sitting together, how to shorten the development time or how to do the technology transfer from the Taiwan to the India. Then India as a manufacturing hub or India as a software development hub to do the cooperation in the infrastructure. So this kind of concept is another one I'm going to point it out here. Except the infrastructure, I think this is more important I'm going to show here. So there are multiple type of the communication protocol. I think from the global standard, they are having a CCS. They also have a Japan, the JATEMO standard. Even India right now, India right now having a BALA standard. So there are multiple different type of the charger, different type of the standards. So the infrastructure, when you build it out, you have to consider different vehicles. They will have a different infrastructure requirement. So from here, if you look at this localizations, fully utilize the engineering resources who understand about the India government policy, the EV policy is necessary. So that's why if for the Taiwan player, if you want to go to the India, you have to hire or looking for the local engineering to do the local development. From the left, the yellow, the orange color pointed out here, this is the solution. Actually, we are using our engineering resources in the India, especially in the Gurgaon, we have an R&D center. At the Bangalore, we have R&D center. We fully utilize our engineering resources to develop the EV charger through our engineer from the India side and to fulfill the local market requirement. So this is the concept I'm going to share with all the players. If you would like to go to India, using the local resources is very important. in order to go for the EV. So from the right-hand side, this is also a very important. If you look at this product, what we are developed, actually we have a multiple different kind of the standards in order to fulfill the requirement. Actually, there are there are multiple standards. So we have to fulfill the market requirement in order to help or to let the user user-friendly in infrastructure. So, okay, I'm going to have a very short idea, especially for today attendee. So I'm using this. So if you look at the map, India actually is the hub of the center of the world. It's very easy to go to the Southeast Asia. It's very easy to go to the Asia. Also very easy to go to the Middle East, Africa, even go to the Europe. Every distance, something around 4 to 5 hours, you can reach that location. And India actually, as everyone knows that, and India actually having a very good engineering college, engineering resources. IT is a software. IT is the strong part of the India, and the IT hardware actually that is a strong part of the Taiwan. If both of us can hand-to-hand co-working together for this particular field, especially in EV portions, it will grow very fast. Especially what I list out here from the cloud service, and right now everyone is talking about the share economy, the apps development, customized interface. So this kind of the concepts is also another selling point for the India to go to the global market. I'm just using sorry. I'm just using the one idea to give you more concepts. So if you look at this, Taiwan, we have a small, actually it's a Taiwan small island. So we are rely on the partner who having a very good in the manufacturing. Since India actually is the next manufacturing hub in the global, we can fully utilize the India resources from the supply point of view, supply chain point of view, from the engineering point of view, from the manufacturing point of view, and from different point of view. India playing very good player to enter the global market, and the distance to the global market is very short. It's only 4 to 5 hours. That's very important. We have to planning right now and hand to hand with our India supplier into the EV field. So in conclusion, I make it very simple. So India as a manufacturing hub, this is very important. Actually, everyone know that next will be the India world. Manufacturing hub is very important in the India. Distribution, since English is an India is an English speaking language. So everyone is speak well in English. So either using the distribution, service center, or the education center. That is an important field for India to provide this kind of the service. On the other hand, global hubs, if you look at the geography location and also the spare part, that two portion are playing very good player. I mean, for India to go to the EV market. So I just pointed out this kind of the from the different angle, from the India point of view, Taiwan point of view, from the manufacturing side, from the vehicle side, from the infrastructure side, and also the business strategy side to give you the overall picture. So this is a very short sharing with you. I think it will be help you to understand more about the EV opportunity. And if you have any further information or the to be checking with us, this is our contact. I'm sitting in the Taiwan, the headquarters here. and we have a colleague located in Gurgaon, Manish Walia, who is a business head in charge for the industrial automations and also the EV related. We also having a colleague located in Bangalore office. One is the north, one is the south, Manikanan. So he is the e-mobility business development manager. So very short, but I hope this kind of information can help those attendee today to have an overall picture how to cooperate together. This is the idea from my today event I'm going to share. Thank you for everyone.
Thank you, Mr. Chen. Nandri. It was a very nice presentation, and thank you very much. And there's a lot of good information for the audience. Thanks a lot. Now I'll request the representative from TIIC to make a brief presentation on how TIIC can help MSMEs in Tamil Nadu to do their business better, and what are the areas in which they can help. Thank you.
Sir, can I come in for a minute? I'm Raju.
Yes,
sir.
Yeah.
Yeah, just wanted 1 minute, just to to thank. Can you hear me, sir?
Yes, Raju. Yes.
Yeah, so just wanted to to thank everybody for the participation on behalf of ELCINA, and also wanted to apologize for the change in the program at the last minute. So I hope nobody has been inconvenienced too much. We will be having the B2B sessions immediately after this session, which is about to conclude. So we would like all those companies who are participating in the B2B to kindly stay back in the hall from the India side, and our Taiwanese counterparts would be available online in the various kiosks which are there on the side. And of course, all of the other delegates may kindly proceed for lunch and enjoy lunch, and then after lunch we will have our session with the senior government officials who are with us, for which we have we'll be having Mr. Krishna online with us, the industry secretary, and Mr. Hansraj Verma, of course, sir, he is there, and we are very grateful for his presence. That's all that I have to say, sir. Thank you very much. Ma'am, please continue. Thank you so much.
Okay, sir. Good afternoon, everyone. I hope everyone will be hungry. I won't take much of your time. I will just brief introduction about Tamil Nadu Industrial Investment Corporation. I want to start my speech with one Tirukkural. I hope all you know Tamil. பொருள் கருவி காலம் வினை இடனுடன் ஐந்தும் இருள் தீர எண்ணிச் செயல். This is the 675th Kural in Tirukkural, you might know. For any entrepreneur to be successful, Thiruvalluvar has narrated the way how to be a successful entrepreneur. Before starting on any industry, the entrepreneur should analyze finance, equipment, timely implementation, technology, and the location of the business. For enabling the entrepreneur to be successful, Tamil Nadu Industrial Investment Corporation was incorporated during 1949 to foster industrial development in Tamil Nadu. Now TIC is a premier state financial corporation with 73 years of valuable experience in MSME lending. TIC's vision is to be the growth catalyst for Tamil Nadu's economy, thereby accelerating Chief Minister's vision for $1 trillion USD economy by 2030. TIC's mission is to position the brand TIC as lending plus value proposition, under which TIC has forged a partnership with various stakeholders in the MSME ecosystem and offers its clients a bouquet of services comprising of lending, financial services, technical guidance, marketing assistance, competency building, raw material sourcing, and other services. TIC has entered into 11 MOUs during 2022. The major MOUs are MOU with NIT Trichy, SRM Vadapalani campus, and Codicea Innovation Center for promoting the startup ecosystem in the state, by complementing the efforts of the government of Tamil Nadu by providing adequate financial assistance to startups in the state. Then MOU with Tanstia FNF Center for promoting technological upgradation of MSMEs by way of adoption of Industry 4.0 standards to make them future ready and globally competitive. Then we have entered into MOU with the Confederation of Indian Industries and Society of Indian Defence Manufacturers SIDM. Through this partnership, we have identified champion MSME industries in 5 nodes, that is at Chennai, Trichy, Coimbatore, Salem and Hosur. They will be enabled with guidance and support for enhancing their managerial and technical capabilities to meet the demands of the defense sector. We are guiding them how to acquire the orders from defense industry. Then MOU with TAN SITCO and SIPCAT for providing, we are providing bridge loan for the for acquiring the plots in SITCO and SIPCAT industrial estates under industrial infrastructure initiative scheme. Then other MOU with Taiko Bank for providing working capital facilities to MSMEs. Then MOU with NSIC for providing raw material assistance to MSMEs. Then we are also entering with BHEL Trichy to promote the BHEL ancillary units at Trichy for acquiring defense orders. TIC is playing a major role in financing of MSMEs in Tamil Nadu, thereby developing job creators instead of job seekers. We provide long-term financial assistance for creation of fixed assets required for an industry both in manufacturing and service sector. Around 90% of our assistance goes to MSMEs. That too 60% of loan is contributed towards new units, that is greenfield units. TIC has the major advantage of being the nodal agency for state and central subsidies for its customers, so that the clients can get both loan and subsidy under one roof. The biggest advantage is the interest subvention of 6% for micro and small enterprises and 3% for medium scale enterprises. We are having many schemes, tailor-made schemes. Even our CMD has come. He is a man of MOUs and new strategies. He may enter MOU with ELCINA also. We will formulate the new schemes as required by your industries, sir. So I request every one of you to make use of the facilities available in TIC so that we shall grow together. Thank you.
And we'll now break for lunch, and those of you who want to continue with the B2B meetings, please do so, and we'll reassemble here at 2:30. Thank you very much. And in the afternoon, as you know, we have a session where Mr. Verma will be speaking, and the industry secretary will be speaking, and the representative from TITCO and Mr. Shashikumar Gendam, MD Salcom, they'll all be talking. Kindly stay back after lunch. Thank you.